Welcome to Study Loop.
Let's take a look at the questions. So the question 1 is asking us to draw a ray diagram to explain why you see a pattern of bright and dark bands on the screen. Show the path difference. Okay. Well, so in this case, I draw two diagrams so you guys can see it clearly. But if you guys want to combine two into one, that's fine. But I will show you my diagram real quick. So let's go to the first page. Okay. So that's what I got, and you see it's a double slit. So the separation of the slit is 0.4 millimeter, and it's angle theta when you shoot into the through the slit and go through the onto the screen. And there's angle theta here as well. And see when you see a first bright band on the screen, and you see the wavelength is lambda. And the reason why I say is because in order to form a bright band, especially on no matter first one or second one, it must be constructively interference. So since it's constructively interference, that means it's m lambda, and m can be any number 0, 1, 2, 3. Since we are looking at the first one, so m is equal to 1 because m cannot be equal to 0 in this case. If m is equal to 0, it's gonna be on 0 band instead of first bright band. So m equal to 1, which is lambda. So it's lambda here. Okay, and for the graph of the first dark band will be something like this. Sand slit, sand screen. Separation of slit is 0.4 millimeter. Distance between slit and the screen is 5 meter. Okay, so the first order of dark band will be shown on the screen like this, and angle is theta. Okay, but the wavelength will be lambda over 2. And the reason why is that is because in order to form a dark band, the waves must be destructively interference. And that means it's m plus 1 half lambda. And m can be equal to 0, 1, 2, 3. And since there's a 1 half plus with an m, so m in this case can be equal to 0. So it will be just 1 half lambda. So when a wavelength is 1 half lambda, the first order dark band will be shown up. And the path difference is already shown here. It's from 0 to the first order of dark band. Okay? And for question B, it's asking us to determine the angular deflection of the light to the first three bright bands when incident on narrow slit separated by 0.4 millimeter. Okay, so let's look at, since there are three angular deflections we need to figure out, let's do it in order. Okay, so, well, what's known here? Well, first we know for the first angular deflection, m should equal to 1. Okay, so m is equal to 1. Lambda, the wavelength, is equal to 630 nanometers. 630 nanometers. And D, which is the separation of slit, is 0.40 millimeter. And we don't know the theta 1, but we will figure out soon. And we know the formula, sine theta m equal to m lambda divided by D. So m equal to 1, so sine theta 1 is equal to 1 times 630 times 10 to the negative 9 meter divided by 0.40 millimeter. And we know 0.4 millimeter is just 10 to the negative 3 meter. And it will give us, let's use calculator real quick, 630 times 10 to the negative 9 divided by 0.4 times 10 to the negative 3. Okay. It will be 0.001575, and theta 1 would just be equal to the inverse sine function of this, which should give us 0.09 degree. Okay, that's theta 1. Okay, let's figure out theta 2. M equal to 2. Lambda is the same. 630 nanometer. These 0.40 millimeter. Theta 2 we need to figure out. So sine theta 2 is equal to 2 times 630 times 10 to the negative 9 meter divided by 0.4 times 10 to the negative 3 meter, and we got 0.00315. Use inverse sine function. We got theta 2 is equal to sine negative 1 0.00315, which is gonna give us, say, look, 0.18 degree. Okay, that's for theta 2. Okay, and for theta 3, m equal to 3, lambda equal to 630 nanometer, d equal to 0.40 millimeter. Theta 3 is equal to, we don't know. Yep. Oh. So we can use this. Sine theta 3 equal to 3 times 630 times 10 to the negative 9 meter divided by 0.40 millimeter. Another word is 10 to the power of the negative 3 meter. Okay, and that will give us 0.004725, and theta 3 is just simply inverse sine function of such value, and that will give us something like this, and which is about 0.27 degree. Okay, so we figure out all the angle deflections for this question, and let's look at the last question. I mean, not last question, my bad. Question C. Okay, determine the spatial separation of the centers of the zeros in second order bibands when projected on a screen located 5 meters from the slit. Okay, take a look. So we know L, which is the distance between the slit and the screen, is 5 meter. Lambda, the wavelength is 30 nanometer. D is the separation of the slit, which is 0.40 millimeter. And we need to figure out Ym, which is a separation of a spatial separation. So Ym is a spatial separation, and we need to figure it out. And there's an equation for such question, which is Ym equal to ml lambda divided by d. And that will give us the m for this case is 2 because it's talking about the zeros order band and the second order band. So m is 2. M equal to here. M equal to 2. Okay. Times 5 meter times 630 times 10 to the negative 9 meter. 1 nanometer is 10 to the negative 9 meter. 0.4 times 10 to the negative 3 meter, since 1 millimeter is 10 to the negative 3 meter. And that would give us something like this. 2 times 5 times 630 times 10 to the negative 9. Okay, divided by 4 times 10 to the negative. Yeah. Okay. So therefore, we'll get something like this. Will be 0.016 meter, which is also equal to 1.6 centimeter, because 1 meter is equal to 10 to the power 2 centimeter. So the spatial separation for this question is 1.6 centimeter. Okay. And for the last question, what kind of assumption we can make? Well, according to all the calculation, we're just passing through. So we can get some assumption from the calculation we just did. So we can assume that light pass through our slit is monochromatic, since we're only talking about one wavelength in this case. And we also can assume that the angular deflection is really, really small at the first few bright bands, and as we can tell, it's extremely small. We just did it. First one was like 0.09 degrees, second one was 0.18 degree, and the third one is 0.27 degree. And those angles are really, really small. Okay, and that's the assumption we can make from these questions. And thank you.